when you do chemistry, right, you have reactants, A plus B, that get turned into products, C plus D, or something like that. And there's a particular rate with which that reaction occurs. So if we have reactants become products, right? This is, I mean, I'm making this up totally, A and B, chemistry magic happens, and you get C and D. There is this arrow represents the chemistry magic, right? And there's a particular rate with which that conversion will happen. I'm not talking about being catalyzed or uncatalyzed, I just mean the chemistry itself. And most reactions have both a forward and a reverse rate, right? Almost all of them do. But there is a tendency in one direction or the other. That's why we call things products and reactants. Does that make sense? This reaction will proceed until what? Equilibrium. Don't say saturation. Doesn't have anything to do with it. Sort of doesn't. Not yet doesn't have anything to do with it. So it will proceed until equilibrium. And equilibrium is at what point? Somebody tell me in just real common sense terms, what does equilibrium mean? Laura?
When the rate of forward reaction equals the rate of reverse reaction?
Almost. No, I know what you're trying to say, but that's not, you didn't say it the right way, because what you would tell me would be that these two arrows would always be the same rate. I know what you're saying, though. You just didn't say it quite right. I know what you mean. Carlo?
Reactants and products are equal?
I don't like the word equal.
Okay. Or the same.
So will be all the reagent at the lowest energy state?
Yes, that is true. All of the reactants will be, this reaction will proceed until all the reactants are at the lowest energy state possible. That sounds so confusing to me. I want simple. What's equilibrium?
The reaction seat stops.
The reaction never stops. It's stable. Constant, stable. It's when there is no more change in the relative amounts of products and reactants, which I think is what Laura was trying to say, but it doesn't mean that they both have the same forward and reverse rate. It could be almost all products, right? Or it could be almost all reactants, but it's when you're at equilibrium is when there's no more change in the amount of reactants and products. Is that okay? You understand what I'm saying? So we start by having all reactants, right? And over time, some of those will get converted to products. Will all of them get converted to products? Probably not. But equilibrium is reached when there's no more change in reactants or products. This reverse reaction rate is proceeding, this forward reaction rate is proceeding, and we've got mostly products or mostly reactants. Is that kind of okay? Does that kind of make sense? I could be wrong, I'm not a chemist, so. Again, don't say this in chemistry class. And you know you can, for every reaction, there is what we call an equilibrium constant. And this value is characteristic for every specific reaction. So every specific reaction, no matter what chemistry we're talking about, has a very specific equilibrium constant. And it is this, right? It is the concentration of the products over the concentration of the reaction. Is that right? I think I'm right. I'm hoping I'm right.